Now, our topic for today is thermal expansivity. From the name, thermal means heat, that is the expansion caused by heat. And we will get in our previous topic, we studied difference between heat and temperature. And one of it is that heat is a form of energy, while temperature is not. And we try to list the effect of heat on object. And one of that is that we said it can cause change in shape. So inshallah, today's topic will be based on that particular effect. Because heat is a form of energy, heat can do something on object. It can do work. So one of the things that it can do on object is to cause an object to expand, to change in shape, to change in area, in length. So today's topic will be based on that. Now, what are the major cause of that? So what does it do on object to cause that particular expansion is that it breaks the force of attraction between the molecule of the object. And therefore, there are two major things that we need to consider. The first one is the state of object. Therefore, the object in gaseous state will expand faster than that of a liquid, while that of liquid will expand faster than that of a solid, because the force of attraction between the molecule of gas is less compared with that of a molecule of liquid, and that of liquid is less compared with that of a solid. So therefore, the solid will expand, the liquid will expand more than that of a liquid, and liquid will expand more than that of a solid when we supply the same quantity of heat. Now, another thing is, even within the same state, take for instance, when we have two different solid material, like when you have copper and iron. Let's say this one is copper and this one is iron. So when you supply the same quantity of them and they are of the same length or the same volume, so you discover that copper will expand more than iron, because the force of attraction between the molecule of iron is greater than the force of attraction between the molecule of copper. Though, because the heat itself require, the function of heat is to break that particular force. So we need to consider the nature of the material and the state of the material. Now, the so-called heat that we are saying, can we say is very good for us? Then it's very good. It serves as what? It has its own advantages to us, especially in our real life. And don't forget, anything with advantage must have disadvantage. So I have some advantages of expansion here, and I have some disadvantages of expansion. Let's start from advantage first. I said expansion, we can use expansion to remove what? Stopper from bottle. When you have bottle and the stopper inside, you find it difficult to remove. What you just need to do, don't put the bottle inside the fire, but just place it very close to the fire like this. After some time, you see that the bottle will expand and give room for the what? Copper to be, stopper to be removed easily. Now, another one is to fix iron rim in the wooden wheel. Don't forget that wood will not expand when you heat it. But what will happen to this one? This one, metal will expand. In that case, it will give room for what? The wooden wheel to enter and fix properly. Then another one is what? Bimetallic strip in thermostat. Fine. That one is common. It's what we normally experience, especially when we are using our electric iron. You see that most of them, especially those ones that have a control, when you are using them, you just discover that they will off themselves. And why? After some time, they will on themselves. It's not magic. What is happening there is as a result of expansion in bimetallic strip inside. Now, we have inside that iron, we have two wire like this. We have this one, then we have this. Then there's one wire inside. So by the time you on your iron, so the current that is flowing is connected to this. So this one will stop the flow of current. And don't forget, anything that stops the flow of current will get hot. So in that case, this one will get hot. So by the time this one is hot, it will expand. The moment this one expand like this, it will disconnect this wire like this. So it will now look like this. So you just discover that the iron will off itself. And as you are using it in that condition, what will happen? It will be getting what? Cooling. So at the end of the day, as this one is getting cooling, that is, as the heat is removing from it, the length of this one will be what? Reducing. So at the end of the day, after some time, this one will come back to this place, and the circuit what? Will reconnect, and you see that the iron will on itself. So that is what? One of the real life applications of expansion. Another one is we still use it what? Red hot refit in shipbuilding. So we have this one. These are the some of application of expansion. We still have disadvantage as well. Like I said, one of it is what? Cracking of what? Concrete building. Yes, if you see some buildings, you just discover that the wall will just crack, not because of anything. It may be firstly maybe the because of heat, and inside that wall there will be what? Iron inside. Then iron will like to expand. Then if the room, I mean, if the concrete does not give what? The room for the expansion, what will now happen? It will force the concrete, and concrete will just what? Crack. So in that case, it is serving as what? Disadvantage to us. So another one is cracking of what? Glass cup. If you put hot water inside the glass cup and you cover it, at the end of the day, you see that glass cup will what? Crack. Especially if they are made of what? Different material. Now, another one is what? Collapses of what? Bridges. Yes, that's why when you are walking along the bridge, you see that they left some spaces. The function of the spaces they left is to give room for the expansion of metal inside. So when you have two different metal like this, if you arrange them like this, very close to each other, by the time this one want to expand and this one too want to expand, what will now happen? They will just push each other, and at the end of the day, it will look like this. So this one can cause what? Collapses of what? The bridge, and it also occur in the what? Our railway line. That's why when you are walking along the railway line, check that the rail. You see that they did not arrange it close to each other. They left space between one another, so that when the first one wants to expand, say when this one wants to expand, just to expand like this one to expand, especially when the weather is hot. So at the end of the day, when the weather is cold, they will return back to their normal size. So in order to give room for what? Expansion, they will leave what? Space. And that is what? In that case, the expansion is serving as what? Disadvantage. Because if that space is not there, what will happen? It will cause delay of the what? Of the train. Because when train is good, train cannot just be turning like this. It just go like this, and it will cause what? Delay. So another one is what? I said it, expansion of what? Railway line. Then expansions of balance wheel of the clock. Yeah, this one too is common. See, most of in the olden days clock, the balance wheel that always rotate, there's something inside it. The olden day clock, their own were made of what? Metal, such that when that metal want to expand, it will just hook the wheel, so the wheel will not able to move again. So at the end of the day, you think as if it was the battery. You remove the battery and replace it. In the following day, the same thing will still occur. The major thing that's happening there is that the metal that is inside that wheel is expanding, and when it contracts, it will release, the thing will continue moving again. So now, and most of our present clock, what is, we check it, what is there is no, it's not more metal, it's plastic or rubber, in order to avoid that expansions of what? Metal. So in that case, it's also serving as what? Disadvantage. So we have advantages of expansion, and as well we have what? Disadvantages of expansion. These are the some of them that I have on my screen. Then the next one is anomalous expansions of water. Now, we said when you apply it to an object, generally we are expecting that object to expand. But when you remove it from the object, we are expecting it to contract. But in case of water behave abnormally, and abnormally unexpected is what they refer to as what? Anomalous expansion. Anomalous means abnormal, something that is not normal. The normal thing is when you apply it, the objects what? Expand. But in the case of water, so especially when you have water at 0 degree centigrade, when you supply heat to water at 0 degree centigrade, we are expecting it to expand. What will now happen to the water? Water will contract until it will get what? 4 degrees centigrade. After 4 degrees centigrade, it what? It will expand again. You can see that abnormal behavior at 0. So the expectation is that the moment it starts expanding from here, it will continue like that until it will change from one state to another, from one state to another. But in case of water, at this 0, it will contract. From getting to 4 degrees centigrade, it will expand. So immediately after 4 degrees centigrade, water will expand in volume. Therefore, water has its minimum volume at 0 degrees centigrade. Minimum volume at 0 degrees centigrade. Then let's relate it to the density of water. You see one graph on my note, so you compare it. And those of you that normally watch my video, anytime you watch video and you need notes on it, please just alert me. I will send the note to you. So at 4 degrees centigrade, water has minimum volume. Then what will now happen to the density? Since density is equal to mass over volume, so if you look at it, it means density varies inversely with volume. If you increase volume, you are reducing density. If you increase mass, you are increasing density. Now that the volume is minimum at 4 degrees centigrade, it means density will go maximum at 4 degrees centigrade. In conclusion, water has minimum volume at 4 degrees centigrade, but maximum density at 4 degrees centigrade. So the next video will be based on linear expansivity, area expansivity, cubic expansivity, real and apparent expansivity, which is the continuation of this thermal expansion.